Okay guys, based on votes, we are looking at trig today. So I thought that we would just work through last year's trig exams. Yes, we are, not trig exams, trig questions, I mean. Yes, we're doing trig only. But guys, I do want to... Hi Ayanda! Welcome! I do want to just let you guys know that there are geometry videos on my YouTube. So if you click on the link in my bio, I record all of my lessons and I then post them on YouTube. Now, in grade 12, I'm not sure if I posted my grade 12 Euclidean geometry videos, the similarity stuff. I might have, but I had an AP class this year, so I went through it quite quickly. We didn't spend ages and ages on it, but my grade 11 Euclidean geometry videos, which is all that circle geometry stuff, I recorded every single lesson, step by step. I've put them on my YouTube. They are numbered in order as well. And yeah, I think the way, my class seemed to really understand it quite well in the way that we, that we started from beginning to end. So I please want to urge you, if you are feeling uncertain about circle geometry, go watch those videos. Especially the videos towards the end was just where we were marking quite complicated questions and I went through it step by step. I worked through it with them. So there is some geometry stuff for you guys to go look at. All right, but we're going to look at the trig stuff. The proof videos, I don't have all of them. I have the circle geometry proof videos. Yes, they are on my YouTube. I don't have the triangle proof videos, but those are not in the exam guidelines, so I don't think they'll ask them. But yeah, the other ones I do have. Alright guys, let's get going. So this is from last year. Question 5 was the first. Let me just turn this music down a little bit. We are focusing on trig today. Alright, now, if you look at the exam guidelines, they have a breakdown of how many marks are awarded for which topic. Now, if you look at that, you'll see that trig is actually 50 marks of the 150. Now, that is a lot, guys. That is a third of the paper. Okay, so 50 out of 150 marks will be trig. And the reason for why it's so much is because trig shows up in so many different topics. So we have trig graphs, for example, which we're going to work through. Then the next question was these kinds of algebraic trig, I almost want to call it. And then you're doing proving identities. There wasn't even an identity question in this paper. They could ask you one. Finding without using a calculator the value, general solution. This was like a problem-solving type question that we'll look at. And then there was the three-dimensional trig as well. Alright, so trig comes up in lots of different ways. Another thing is, so I am hoping that TikTok will save it. Just with my last live, TikTok didn't save it for some reason. Something went wrong. It might be because I tried going into it before it was done saving. I just opened to see if it was done and it was still busy. And then when I went back on, it said that something went wrong. So I'm just going to leave it for like an hour after today's live and then hopefully it will be there and I'll post it to YouTube. But what I was saying is also often trig comes up in the analytical geometry questions. They often ask an area question in analytical geometry. If we're done with this before 5, then I'll show you guys. But they often ask like find the area of this kind of triangle or this shape. You then have to split it up into other shapes. So you would have to split it up into maybe a right angled triangle and then a triangle that's not right angled. And then you would have to use your area rule, which is the sine cos area rule, that chapter, which is also technically trig. So trig can come up in lots of different sections, which is why it counts for so many marks. Okay, we're going to start with the graph question. And guys, in my tips for on the day of the exam video, which is on TikTok, I said there that you should always attempt all of the questions. I think lots of people just think, oh, I don't like trig graphs, I'm going to leave out the whole question. That is absolutely not the right thing to do, guys. All of the questions in your exam start off with quite simple questions. You'll see now when we look at this one. The first 3 questions of this exam, this question 5, was very simple. It's almost like 3 guaranteed marks for anyone. And if you just skip that because you think you're not good at trig graphs, then you would lose out on those marks. So I want to urge you to at least try at least the first few questions of each question. What they do is they do tend to ramp it up towards the end. So you'll see the last question, the last two questions of this question 5 were the difficult ones. In question 6, same thing. Some of these are quite simple. So 6.1.1 is easy, 6.1.2, then 6.1.3 was difficult. Then that was manageable, this was all right, and then this was difficult again. So yeah, please don't just leave something out on principle. Attempt the first few questions, and then if you see that you've got into a question that you really can't do, you really don't know what to do straight away, leave that out and come back to it at the end if possible. All right, if you have time at the end. Okay, so for question 5, they've given us two equations here. They're saying f of x is -1/2 cos x, and g of x is sine x plus 30. Now, what they've done also, if we're looking at the diagrams, is they've actually labeled these graphs. But guys, they don't have to do that. Okay, they can give you the diagram, they can tell you the equations of the two graphs, and they might not label them. You need to be able to look at these two graphs and figure out which one is which in case they don't label them. So, for example, if we're looking at this one, this is saying -1/2 cos x. Now, we need to know what a cos graph usually looks like. The basic cos graph. It will end at 5. Now, the basic cos graph, if I can just draw a rough sketch here, will start at the highest point, go down to -1. If it's just a graph of cos x, y equals 1 cos x, it will start at 1, then at 90 degrees it will be at 0. At 180 it will be at -1, at 270 it will be at 0 again, and at 360 it will be at +1. That is the basic cos graph, the graph of y equals cos x. Now the graph that we are working with here is -1/2 cos x. Now guys, what the half does, this is the a value, alright? So we say that a is equal to 1/2. Now a is the amplitude. The amplitude is the distance between the x-axis in this case, because the graph didn't shift up or down, so the x-axis is going to be the middle axis essentially of this graph. So the amplitude, 1/2, is the distance between the x-axis and the highest value of that graph, and it's the distance between the x-axis and the lowest value on that graph. So if the amplitude is 1/2, this graph would start at +1/2 and go down to -1/2. But now our a value is also negative, meaning that the whole graph actually reflects in the x-axis. So instead of starting at the highest point, this graph is going to start at the lowest point. So let's look at this. This is the graph of f. Okay, they've indicated it here, but like I said, you need to be able to identify that if they didn't indicate it. Now what we can tell from this is because it's -1/2, this value here, this y value of this point, is -1/2. Okay, you have to be able to figure that out on your own, because that is where the graph would start. So we know, I'm just going to go over that again quickly. The cos graph usually starts at the highest value, which is 1, because it's 1/2 cos x, the highest value would be 1/2. But now it's -1/2, so it's going to start at the lowest value and go up. Alright, which we do see is happening here. Guys, this is just from 0 to 180, so it's basically only half of the full period that they've shown us here. Okay, so that is f. Now if we know that, then we know that this is -1/2, and then at 90 it's at 0, and then at 180 it's supposed to be at its highest value. So this point, actually, we can figure that out, is 180 and +1/2. Alright, we might have to use that, we might not. Thank you, that's such a lovely compliment. Thank you so much. Alright, so now, oh, did someone say something rude? It always happens, don't worry. Okay, so now, so that's f. Now when we get to g, this is sine of x plus 30. Now guys, if it's plus 30, alright, that means that this sine graph has shifted 30 degrees to the left. Okay, if it's a plus 30, Why would the 180 go first? Because it's the x value. All right, and when we're writing points down, we always do the x coordinate first and then the y coordinate. So the x coordinate here is 180. Yeah, just comment on one of my videos. Someone asking here about the rewrite. Yes. Okay, back to this. So when it's x plus 30, that means that, let me just move this a bit. That means that your graph is shifting 30 degrees to the left. Guys, the sign in the bracket is always the opposite to the direction of the actual shift. So when it's a plus 30, you're moving 30 degrees in the negative direction. So 30 degrees to the left. Okay, if this was sine x minus 30, then you would move 30 degrees to the right. Okay, now I'm just going to quickly draw the basic sine graph. Okay, so it would start at the origin, go up to the highest value. This is at 90. At 180, it would be back at 0. At 270, it would be at -1. And at 360, it would be 0 again. Okay, so that is the normal graph. This is the graph of y equals sine x. Now, if it's sine x plus 30, the only thing that's changing here is that this point, the whole graph in fact, but if we can just focus on this point quickly, is actually shifting to -30. So if we're looking at this graph of g, right, maybe, and I'm hoping that it will make sense, that if you were to extend this graph, if you were to continue drawing that graph, that it would have its x-intercept at -30. Okay, they didn't draw it that far because this graph is just going from 0 to 180, but that is where it would start. Okay, so it would have exactly the same shape as that basic sine graph, but it would just, instead of having its starting point at 0, 0, it would now actually start at -30 degrees. Okay, so we can see that. And just remember, guys, I drew this in here. It wasn't on the actual given thing. All right. Now they're saying that A, which is the point 130,9 degrees and 0,33, that's the y value, is the approximate point of intersection of the two graphs. All right, so they've given us that point of intersection. And guys, just a heads up, if they're giving you that point, you're probably going to have to use it. Okay, so take note. Make sure that you are, taking note of the fact that they've given you that. Remember that point. Okay, we're probably going to have to use it, otherwise they wouldn't give it to us. Okay, now, next question, or not next question, first question, 5.1, write down the period of G. Now guys, the only thing that changes a period of a trig graph is the K value. All right, so if you have A sine K x minus P plus Q, all right, that is the basic, oh, thank you for the rose. That is the basic, or the standard form of a sine graph, okay? They will never give you all of these shifts. You can see in the case that in these two graphs, they've only given us that shift 1 and that shift 1. Okay, so they've only actually done one thing, but these are all the different things that could happen. Then we have the same type of standard form for the cos graph. And I'm just quickly going to run through what each of these variables would represent. And we have the same thing for the tan graph. Okay, so now A is the amplitude, all right? In the case of a tan graph, I'm sure you guys know this, a tan graph does not have an amplitude because a tan graph doesn't have a highest point and a lowest point, right? Because a tan graph has this kind of shape. It continues all the way down to -infinity, all the way up to +infinity, all right? So a tan graph doesn't have an amplitude. It could have an A value, though. Sine and cos, these two graphs do have amplitudes, all right? So in the case of G, this highest point, now we can't really see it here, okay? It would be there somewhere. And the highest point is actually going to be at 60 degrees here and 1. I can talk about how I know that that's 60 just now. All right, so the highest value of this graph is 1, and the middle value is 0. So the distance there, the amplitude between the middle value and the highest point is 1. So the amplitude is 1. For this one, the distance between the lowest point or the highest point and the middle value, which is 0, is a half. So this one has an amplitude of a half. Okay, so that is what the A value represents. K K is the one that we're looking at now when we're talking about the period. If you have a K value there, all right, now K is either in front of a bracket or just in front of the X. If there was no sideways shift, then there wouldn't be a bracket. So if you had something like sine 2x, for example, all right, then K would be 2. Now K is the value that changes the period of a graph. So for sine and cos, we know that a sine and a cos graph has a basic period of 360 degrees. But if there is a K value, like a 2 for example, the new period is going to be 360 divided by whatever that value is. Yeah, I will explain the 60 degrees just now. Okay, we're just on period quickly. So the period of a sine or a cos graph is always 360 degrees divided by whatever K is. For a tan graph, the period is going to be 180 degrees divided by whatever K is. Okay, now in most cases, K is 1. So if we're looking at, they're asking for the period of G, and G is the graph sine x plus 30. Now guys, what number is in front of this bracket? If there's no number written there, then it's actually a 1. Okay, so the K value in this case is actually 1. So that means that the period of this graph is 360 degrees. Okay, I'm just gonna, sorry, I didn't actually get this bottom page ready. Let me just move it quickly to the top. Okay, there we go. Guys, if the comments are in the way, then you can just swipe to the right and then the comments will disappear. So this is 5.1, I think. Let me just check. Yes, so the period of G is 360 degrees. All right, but if it was, for example, if the equation was y equals sine 2x minus 60 degrees, for example, I'm just making that up, okay? I'm just showing you how it would work. Then your period would be 360 degrees, the basic period of a sine graph, and then you would divide it by your K value, by 2. Okay, so that would then be 180 degrees. For this one, because our K value is 1, the period is just 360. Okay, and that's a 1 mark question, guys. 5.2. 5.2, they're asking for the amplitude of F. Now, we have discussed it already. F is this graph over here. All right, the A value of F is negative a half. But, guys, the A value can be negative. I'll talk about the restriction just now. It doesn't actually have an effect on anything here, but it's fine. I'll get to that now. So here for the amplitude, I want you to understand that your A value can be negative, but your amplitude will always be positive. All right? Because the amplitude is a distance. So even though the A value here is negative a half, the amplitude is a half because that is the distance. If we're looking here, the distance here is half a unit. The distance there is half a unit. Okay, the only thing that the negative actually does is it changes the direction. So instead of starting at the highest point, it starts at the lowest point. Okay, so the amplitude, guys, will always be positive. So amplitude of F is a half. Right, and that was also a 1 mark question. But guys, if you said negative a half, you wouldn't get this. Yes, I will. If you said negative a half, then you wouldn't get this mark because the amplitude is the distance and distance can't be negative. Okay, so it has to be positive a half. The A value is negative, yes, but the amplitude is positive. Now, someone asked about the restriction in 5.1. It's not really a restriction. They've just drawn it from 0 to 180, but that doesn't change the fact that the period is still 360 degrees. Because if we're looking at this, right, they asked for the period of G. If we're going from negative 30 to, yeah, we don't have, do you see that you don't have a whole, sorry, this dog is barking now, I'm getting distracted. Yes, amplitude is always positive. The period is just how long it will take or what distance on the x value it will take to actually complete a whole curve. All right, so this graph of G would go from negative 30. There we have the first step of the graph. There we have the second step of the graph. We're still supposed to go another 180 degrees after that. Okay, and then that will be the whole thing. So yeah, even though they've only drawn it from 0 to 180, that is the domain of the graph. Okay, that's not the period. The period is how long it will take for this whole graph to go from the middle to the top, down to -1, back to 0 again. Okay, and it would take 360 degrees. So yeah, someone was asking here how I got the 60-degree point here. And we actually are not necessarily going to need it, but it is good to talk about it. Now, I'm sure that we all are fine with this -30, right? Because the sine graph normally starts at 0, 0. This one has shifted 30 degrees to the left, so this one starts at -30, 0. Now, guys, if the period of this graph is 360 degrees, right? The period of G is 360. There is something called a step. Now, the step is how often you have to plot a point. All right, I'll talk about domain just now. So the step is how often you have to plot a point, and it's always the period divided by 4. So if the period here is 360 degrees, and we then divide that by 4, the step is 90 degrees. And what that means is that there is always 90 degrees between each, we call it point of interest. All right, so on this graph, and I know the -30-degree point wasn't there, but I put it there so that we could get a better idea of this. No, we're not going to go over stats, just trig for today. So I know that this wasn't here, but guys, do we notice that between -30 and 60 degrees, that is 90 degrees? All right, that's how I knew that that was going to be 60, because from my x-intercept, -30, to my turning point, which is the next point of interest, you have to have 90 degrees. Then, from your turning point, which is a point of interest, to the next x-intercept, you again have to have 90 degrees. Now, what is 60 plus 90? It's 150, right? The next turning point, even though it's not drawn here, we could figure out where that next turning point would be. Is it going to be at 150 plus 90, which is 240 degrees? All right, so that is where the next value would be. No, I'm not going to go live tomorrow. Okay, so guys, that is how I knew the 60 degrees. It was literally -30, which was my x-intercept, plus 90 degrees, which was my step. Okay, now if my, sorry, I just got like a pang in my head, like a headache vibe. If my period was 180, okay, so if the period was changed, so say there was a 2 there in front. So if the period was 180, where can I write this now? So 4 for the step, that's just something that you must remember. Okay, that's like a formula. Your step is always period divided by 4. I can't go live tomorrow, guys. I'm sorry. Okay, so this is a formula. All right, step is always period divided by 4. Where was I? What was I going to say now? Okay, so if the period was 180, then your step would be 180 divided by 4. It's always divided by 4, which would then be 45 degrees, which means that you would just add 45 degrees between each of your points. All right, if you wanted to do that. Yes, it's TikTok that didn't save my live last time. Hopefully it will this time. Okay, so we're done with 5.2 now. Determine the value of F180 minus G180. Okay. So the 60 degrees is -30 plus 90, which is the step. -30 plus 90, that will give you the next point, which is 60 degrees. Okay. Determine the value of F180 minus G180. Now, guys, this comes back to function notation, which is something that you also would have been tested on in paper 1 on Friday. Function notation is f of x minus g of x. Now, if they've put values here, I can't do that. It's not like a manual thing that I must save it. It's just TikTok has to save it, and sometimes something goes wrong. But it was just once. It was just once that something went wrong, so hopefully this time it won't. Okay, so here, If they're putting values in the brackets, then that is actually the x value that we're looking at. And that is the x value that we're looking at. Because it's f of x, right? And it's g of x. And we have to find the difference between those two. But now they're telling us we need to find the difference between these two graphs when x is equal to 180 degrees. So let's look at our graph. There we have these values, right? X is equal to 180 degrees at these 2 points. Okay, now we know that at 180, f, oh gosh, I got a fright now. F is positive a half, the y value. Because guys, do you remember that f of x actually means y? So that's actually what they're asking for. When they're asking of f 180, they're asking for the y value of the graph of f when x is 180. So f 180 is actually a half. And g 180 is whatever this y value is over here. Now guys, if you're looking at this, you can actually figure out what it is. But, yes, I am going to. If we're looking at the graph, we could try and read it off. But let's just be certain, okay? Because they didn't give us specific values here. They're not saying in this question that we're not allowed to use the calculator. Okay. So what we're going to do is I'm just going to double check for g, the graph of g, when x is 180, what is my y value? And how can I do that? By subbing x equals 180 into the equation. All right, so sine of 180 plus 30 is negative a half. Okay, now you could see that if you actually looked at the graph, because this point is perfectly in line with that point, which is at negative a half. Okay, but if you're not sure, if you don't want to do it like that, then you can use your calculator. You can sub the x value in, and that will give you the y value. Okay, so the y value of g when x is 180 is negative a half. So now if they're asking for f of 180 minus g of 180, we're going to take the y value of f where x is 180 degrees minus the y value of g when x is 180 degrees. So a half minus negative a half. Okay, I'm going to write that down. 5.3. They're asking for f 180 minus g of 180. Now, f of 180, like I said, is the y value. F of 180 is the y value of f, of graph f, when x is 180. So that is a half. Minus g of 180 is the y value of g when x is 180. And we saw that that was negative a half. All right, so a half plus a half. And that is equal to 1. Okay, where in life are you going to use this on Monday in your exam? How's that? Okay, 5.4. 5.4.1. Use the graphs. Okay, now these questions were quite hectic. Antwoord is nie verkeerd nie, jammer vir jou. Okay, 5.4.1. Use the graphs to determine the values of x in the interval x between 0 and 180. So that's what they've given us here. That's what they've drawn. For which, now they're saying 5.4.1, f of x minus 10 is equal to g of x minus 10. Okay? So 5.4.1. They're asking if x minus 10 equal to g of x minus 10. Now guys, the important thing in the question here is they're saying use the graphs. Okay, that is the important thing here. So somehow we need to use the graphs that they've given us. Okay, now they haven't given us the graphs of f of x minus 10 and g of x minus 10. Alright, they have given us the graphs of f of x and g of x. Now what happens when it's f of x minus 10 and g of x minus 10? X minus 10, that is actually the graph of f moved 10 degrees to the right. Okay, remember if it's an x minus 10, then this is 10 degrees to the right. Ooh, this dog. And g of x minus 10 is also 10 degrees to the right. Okay? Now, what I want you to just look at, remember I told you in the beginning, they're not going to give us the point of intersection if we're not going to use it. Okay, so they've given us the point of intersection here. The dog is barking. Okay, they've given us the point of intersection here. Thank you for the rose. They've given us the point of intersection of f of x and g of x, and that is at 130,9. Okay, 130,9 is the point of intersection of f of x and g of x. Now guys, what's going to happen with f of x minus 10 and g of x minus 10? That is just both of these graphs shifted 10 degrees to the right. Now I hope that it makes sense that if both of these graphs shift 10 degrees to the right, they are maintaining their shape, they're doing their whole shape, they're keeping it, it's not shifting up or down anything, it's just shifting 10 degrees to the right because it's x minus 10, right? So if these two graphs shift 10 degrees to the right, I hope it makes sense that the point of intersection will also shift 10 degrees to the right. Right? I'm going to say that again. It is a bit complicated. They're saying use the graphs. So somehow we need to figure out how we're going to use the graphs in order to solve this equation. They're asking where is f of x minus 10 equal to g of x minus 10. Now these two graphs are just f and g shifted 10 degrees to the right. Now, if both of those graphs are shifted 10 degrees to the right, then the point of intersection will also shift 10 degrees to the right. So what is 130,9 plus 10? 140,9. Okay, that is the answer to that question. So 5.4.1 is at x equals 140,9 degrees. Okay, that was just a 1 mark question. It was a problem solving question, but I hope that makes sense. All right, 140,9, correct. Now guys, this next one, 5.4.2, shoo, this one was a lot. Okay, they're saying use the graphs to determine the values of x. Someone was asking earlier, how would you know if they're wanting the x values? This is what they say. Okay, they literally say the values of x in the question. You're welcome. I'm glad that it's helping. Okay, so determine the values of x in this interval for which root 3 sine x plus cos x is greater than or equal to 1. Shoo! Now, we need to remember that. I'm just going to write the equations that they gave us. F of x, right, was negative a half cos x. Oh, sorry, the page slipped. And g of x was sine x plus 30. Okay, now they're saying use the graphs to solve this. But we have the graphs of these equations. We don't have the graphs of these equations. Now, in order to use the graphs that we have, sorry guys, just hold on.
Do you have a box of matches or a lighter?
Okay, so now, sorry, this is my last live. Yes it is, sorry. Okay, sorry, back to this. Hello. Okay, root 3 sine x plus cos x greater than or equal to 1. Sorry guys, there's a lot going on here now. Just hang on for a second. Someone's saying here, Tala, I got a lighter. Close the door, please. Because that dog. Thank you. Okay, guys, sorry about that. Yes, it is going to be a compound angle. Good. Okay, so, use the graphs to determine the values of x that solve this. Now, like I said, these are the equations that we have. These are the graphs that we have. We can't use the graphs if we actually don't have these equations, all right? So what we're going to have to do is we're going to have to change whatever we have here, whatever they've given us in this inequality. We're going to have to change so that we have one or both of these equations. Okay, so what I'm going to do first. At first, I also wasn't 100% sure of what I had to do, so I just thought, okay, there's a cos x here. The one graph that I have is a half cos x, negative a half, but I thought I can worry about the minus later on. So this is half. So how can I change that cos x to half cos x? Let's just divide by 2 and see what happens. But now, guys, unfortunately, you can't just divide by 2 in one term. All right, if you want to divide by 2, you have to divide every single term by 2. So look at what I'm going to do. I'm just going to write this down quickly. This inequality, 5.4.2. Root 3 sine x plus cos x greater than or equal to 1. Okay. Yeah, I mean, this was a difficult one, but okay. Maybe once I've explained this one, you might be able to notice something like this in Monday's paper if it comes up. Okay, so like I said, we need to try and find the equations or introduce the equations of the graphs that we actually have. So I thought, okay, let's divide by 2. So I'm going to divide this one by 2. I'm going to divide that one by 2. And I'm going to divide that one by 2. Okay, so now I don't really like the look of this. I'm just going to write this as root 3 over 2 sine x, and you will understand why I'm doing it like this in the next step. Cos x over 2 is the same as a half cos x, right? And then this is greater than or equal to a half. Too late now. Okay, so now if we're looking at the equations that we had, all right, we're getting closer to that. Okay, so then I thought, root 3 over 2 and a half. That looks familiar, right? Remember, we're working with trig now. So root 3 over 2 is actually the same as cos theta. I don't know if you guys would recognize that. Root 3 over 2 is the same as cos theta. And 1 over 2 a half is the same as sine theta. Do you guys remember your special triangle? Now, sorry, I'm not using a ruler for this because I only have one hand, so it looks a bit wonky. All right, but if you have your special triangle, and remember, guys, you have to memorize this for Monday, okay? If they say you have to do a trig equation without the use of a calculator, then you have to draw this on the side, okay? Now, you don't have to draw it on the side here because they didn't say without the use of a calculator, but this is what I was thinking about, okay, while I was doing this question. I saw root 3 over 2 and I thought, oh, that looks familiar, right? That comes up in this triangle. Root 3 over 2 is cos theta. Remember, cos is adjacent over hypotenuse. So cos theta is root 3 over 2, all right? So let's replace root 3 over 2 with cos theta. And then I have cos theta times sine x. Now, a half plus a half. Sine theta is a half, right? Sine theta is opposite over hypotenuse. Sine theta 1 over 2. Sine theta times cos x. Now that must be greater than or equal to a half. Okay, now I'm hoping that you guys will notice that this looks like an expansion of one of the trig compound angle identities. All right, where you have, oh, sorry about that sound, where you have sine cos, cos sine. Okay, I'm just going to swap these around so that I have sine cos, like that, plus cos sine, because that's how it shows up on the formula sheet. I'll show you guys now on the formula sheet. Okay, sine cos, cos sine. Now guys, it's okay to do this, right? Because the order in which you multiply things together doesn't change the answer. Like if you have 3 times 2, that's 6. 2 times 3 is also 6. All right, so you can swap the order of these things around. This is last year's November paper 2. Okay, now if we just go to the formula sheet and we go down to the compound angle expansions, do you see that it's this one? Sine cos plus cos sine. So this is what we have. We have sine, let me just double check. We have sine x cos 30 plus cos x sine 30. So we have sine x cos 30 plus cos x sine 30. All right? So now if we have this, the expansion of the compound angle identity, we can change it to that. And what does it become? Sine of the first angle, which is x, plus the second angle, which is 30. So this is actually going to become sine x plus 30 degrees. Look at that. And wasn't that one of the 2 graphs that we had? Okay, so now this is the expansion. We're going to change it using the compound angle identity, working backwards from the expansion to the compound angle. And we get that. Yeah, it is hectic. Let me just check here, the part where you divide. Can you please explain the part where you divide? Yeah, so that is just something that I tried out. All right, so I had this inequality given. I couldn't do anything with it because I didn't have those graphs. So then I just thought I'm going to divide by 2 because I had the graph of a half cos x, negative a half cos x. So if I have cos x and I divide that by 2, then it will give me a half cos x. All right, so that is what I tried to do. In the end, it actually turned out to get me to the other graph equation, which, yeah, was strange, but that's what I did. Okay, I had something that I couldn't do anything with, so I just decided to try dividing everything by 2. Okay, and then when I did that, it gave me root 3 over 2 and 1 over 2, which in the end is actually cos 30 and sine 30, which I could then use the compound angle identity, and I could, yeah, make it simpler. Now guys, sine x plus 30 is g of x. So in fact, I have now changed the given inequality to g of x greater than or equal to a half. All right, but guys, this was difficult. This was a problem-solving question. All right, so yeah, you had to really think out of the box with this one. You will always get a problem-solving question. Yeah, and sometimes you'll think of the right thing to do, sometimes not. Sometimes you'll try some things out. You might get some marks for trying out something. You might not. Yeah, but this is how you had to do this one. Okay, so now we're getting that the question is actually asking, where is the graph of g greater than or equal to a half? Now, if we go to the graphs again, now this page is very busy because I've made lots of notes on it. G is this one, right? Now, again, if you weren't certain, you could just check. You could see on the graph, is this a half? Let's check. What is the y value of g when x is 0? So if we have sine of 0 plus 30, that is a half, right? Okay, so this is, that starting point is a half. Okay? Now, where do I have a half again? You see, it wasn't indicated anywhere. They just have 0,33 here, which is smaller than a half. So it's supposed to be here somewhere. Now, guys, just check. Maybe it's 120, right? It kind of looks like a half is in line with 120 over there. Let's just double check quickly. Let's make our x value 120 in this equation. Let's see. Yes, it is a half. Okay? So that is also a half. This question is asking, where is g greater than or equal to a half? Now, g, remember g of x is the y values. So guys, does it make sense to you that it's this whole section? All of the y values there for that whole section will be greater than a half or equal to a half. Right? Because remember, if they're asking for g of x, let me just write it here. g of x greater than or equal to a half. G of x represents the y values of g. Okay, so this is actually asking on the graph of g, where is y greater than or equal to a half? And it's between these two values. Okay, but now we have to give the x values because that's what they asked for. They asked for determine the values of x. Now what is the x value here? 0. And the x value here, we calculated it, was 120. Okay, so it is between 0 and 120 degrees. What if I just say when x is at 0? You might get 1 mark for that. Although actually in this question, because it was a problem-solving question, it was 1 mark for giving the whole interval. So in this one, you won't get a mark for that. But if it was just a straightforward one, if they had just asked where is g greater than or equal to a half, then you might get 1 mark for just saying at 0. Okay, so it's this section, guys. It's this portion. This is what this interval, this is what we need to write down. Okay, from 0 to 120 degrees. Okay, so that is then the answer. But I want to just put your minds at ease, guys. Like I said, this was a problem-solving question. It was meant to be difficult. Lots of people didn't get it. Okay, because if you didn't think of dividing by 2, if you didn't recognize that root 3 over 2 was cos 30 and a half is sine 30, then you couldn't actually have done this. All right. Now, okay, that was it for question 5. There's a lot going on this page. What would the domain and range for the graphs be? Well, the domain is just from 0 to 180. The domain is always the x values, right? So for a trig graph, they won't ask you for the domain because the domain is what they give you. The range, if we're looking at g, for example, the lowest value on g, if we're looking at this equation, right? It's a 1 sine x plus 30. So the domain or the range here would be from -1 to +1. All right, from -1 to +1, that would be the range for this one. For the other graph, for the cos graph, it will go from -1/2 to +1/2 because of this amplitude, right? So the range for this one would be -1/2 to +1/2. Okay, someone asked if I could do interval notation for this answer. So you could write it as x is an element of square brackets because we're including 0 to 120 degrees, also square brackets because we're including it. Okay, right guys, let's move on. I want to get to the other questions as well. Okay, question 6. I do also want to say that my trig graph lessons from grade 11 are on my YouTube channel, and my trig lessons are also on my YouTube channel. So if you feel like you need more input on these topics, then you can go watch those over there. Oh gosh, there's 300 people here. I didn't realize that. Yes, range is all the y values, correct. Okay, guys. In the diagram, P is the point -512 and T lies on the positive x-axis, and then they're saying angle POT is theta. Okay. All right, so 6.1.1. Now, important, answer the following without using a calculator. So guys, at no point here are we using a calculator. Can I do core? This is core maths. All right, so answer the following without using a calculator. That is important. No, don't worry. It's fine. It's going to be fine. Okay. We are saying they're asking us to write down the value of tan theta. Now, guys, whenever you're seeing this type of diagram, I want you immediately, you can even do it before you've read the question. You're going to construct a triangle. All right, a right angle triangle. That is what you always have to do in these types of questions, where they've given you a Cartesian plane and they give you a point in one of the quadrants. Okay, you're always going to have to construct a right angle triangle. So do that right from the start. Remember, I'm not sure if everyone knows this, but you will get an answer booklet. Okay, you are going to have to write in an answer booklet. So this diagram will be on the answer booklet and you can just draw it straight away. You won't have to redraw this. Okay, and that answer booklet will obviously be all your answers. So whichever diagrams or constructions you do on this picture, the marker will see it. Okay, so now here, if this is a right angle triangle, right? We're going from 0 to point P. Your x value is the x value of your triangle. Okay, the x value, no, it's not that bad. Okay, so I'm just going to say this again. The x value is the x length, I suppose, of the triangle. So on the x-axis, you have a length here. But guys, because it's negative, all right, because it's -5, because we're going into the negative direction of the x-axis, the length is 5, but you have to put a -5 on that side. Okay, you have to put a -5 there. Because if you don't put that -5 there, you're not going to get the right signs. Remember the cast diagram? In each quadrant, each trig ratio has the same or has a specific sign. So if you don't make that negative, then the ones that are supposed to be negative won't be negative. Okay, you have to put that -5 there. 12, the y value of this point is the y length of the triangle. So the y value is 12, the y length is going to be 12. Okay, now you can keep the sign. Yes, you're going to square it, so that's actually not going to change anything. So for 6.1.1, before we worry about this hypotenuse here, we are going to calculate it, but we might not need it for the first one. They're just asking, write down the value of tan theta. The name is Miss Hanekom, but there's a link in my bio. You can just click on there. Write down the value of tan theta. Well, they would have to give you this point, right? So x and y, x value is negative, y value is positive. So they would have to give you this point, and then you can see from there that in the actual point, the y value is positive. Okay, write down the value of tan theta. Now, guys, we are going to use this. Nice. We are going to use this angle as theta. Okay, it's not actually theta, but we are going to just use it. Thank you for the rose. We're going to pretend that that is theta. Okay, I know that it's not, I know it's not, but we're just gonna just put a little theta there. Okay, it's actually 180 minus theta if we want to be absolutely correct. Okay, that angle there, but we're just going to use that angle as theta. Now tan is going to be opposite over adjacent. Do we remember? Tan is opposite over adjacent. So if they're asking for the value of tan theta, we're going to say 12 over -5. Done. 6.1.1. Just move that up. Tan theta is -12 over 5. Okay. Calculate the value of cos theta. Now cos is adjacent over hypotenuse. Now we don't have the hypotenuse. Do we see that? I don't have the test, hey, unfortunately. Okay, so for cos adjacent over hypotenuse, now we need to calculate the hypotenuse. Now guys, in a right angle triangle, if you have two sides and you want the third side, you're going to use Pythag, okay? So to get the hypotenuse, we're going to say that one squared plus that one squared, and then we're going to square root it. So let's see. For 6.1.2, I'm going to call it OP because that is the name of the line. So OP squared is going to be 12 squared plus, now someone was asking, when you do Pythag, do you keep the sign? You can, you don't have to, you can just do 5 squared, alright, but you can do -5 squared, because when you square a negative number, it just gives you a positive anyway, alright, so 12 squared plus -5 squared, this is 144 plus 25, that is 169. Please remember, guys, Pythagoras, okay, last year they actually took a mark off if you didn't write it, this is important. Okay, so now OP is the square root of 169, which is 13 units. Okay, so now we can put 13 in there. Okay, then what were they asking for again? Cos theta. Cos is adjacent over hypotenuse. So cos theta is -5 over 13. Therefore, cos theta is -5 over 13. Yes, you can. Yes. So it isn't, but it would give you the same value. Okay, so yes, you can just assume that theta is the one in the triangle. Guys, I'm not sure. Pythagoras, that's what it says in the CAPS document. So play it safe. You're not going to have to write it a million times. You're going to have to write it once, maximum, possibly twice. Rather just write the whole word. That is what it says in the CAPS document. Okay. Now 6.1.3, this is the kicker. Okay. SAB is a point in the third quadrant. Okay, third quadrant is over here. Such that angle TOS, so TO and then S, whatever is the angle here, all right, TOS, is equal to theta plus 90 degrees, and OS is 6,5 units. Calculate the value of B. So they want us to find the value of the y coordinate of that point S. This is an art line fine liner that I'm working with. Okay. Now, I'm actually going to have to draw a diagram here because this is a bit complicated. So let me just tear this out. It's a bit difficult doing it with one hand. Okay, now I'm going to try do this as neatly as possible without a ruler. Sure. Let me try draw it on here. Okay, I'm just going to draw it quite small. All right, they're saying that S is here somewhere, right, in the third quadrant. We don't know where exactly, somewhere in the third quadrant, S, which is AB. And they're saying now that this angle has to be 90, right, because they're saying that TOS, so we're assuming it's that way around, TOS, because I'm holding my phone with the other hand. I don't have like a good setup, so I have to hold it on top of a pile of books. Very professional. Okay, so here this angle is 90 degrees plus theta, right? Because they're telling us that TOS is theta plus 90. Okay. Theta plus 90, that whole angle is theta plus 90. So that's how I know that that is a 90 degree angle there. Okay. Now, now, what were they saying? They're saying that OS is 6.5 units. Okay, we're going to have to use that. 6.5 units. Let's fill that in. Now, guys, what we are going to have to do here, maybe I actually should have made this a bit longer. Let me extend that a bit so that it doesn't look like it's just that one going. Okay, so this is now a different triangle. It's not the same triangle, guys, which is why I've just extended it a bit. Okay, I'm just drawing again a right angle triangle over there. Okay, so now I want us to look at this bottom triangle. Okay, yeah, this bottom triangle. Now, guys, this again is a problem-solving question. They just said that it's in the third quadrant, so I just made it somewhere in the third quadrant. Okay, you could have made it shorter, you could have made it longer. Yeah, doesn't matter. Just somewhere in the third quadrant. That's how I knew that it's down there. Okay, they said in the third quadrant. Now, they've given us 6,5. Now, do we notice that in this bottom right angle triangle, 6,5 is in fact the hypotenuse? Okay. So I have made a right angle triangle here. 6,5 is the hypotenuse. A, the x value, is this x length, right? So now we're ignoring that -5. That was for the top triangle. A is now this blue length. And B is the y value. So B is the y length. Now, guys, what are they asking for? They're asking for the value of B. Okay, so I'm not even going to worry about A. They're not asking for A, so let's not worry about A. Let's look at B. Now, one thing that we do know is that this whole angle is 90 plus theta, right? That's what they told us. They said TOS is theta plus 90, 90 plus theta, same thing. So, yes, it's just because of this. They said that TOS is theta plus 90. So, if that is theta, then to get theta plus 90, what I must add has to be 90 degrees. Okay, so it's because of that what was given. That's where the 90 comes from. Now, let's look at this quickly. If we're looking at this angle, I have the opposite. That's what I'm trying to find, right? Is the opposite side B. And I have the hypotenuse. Which trig ratio works with opposite and hypotenuse? It's sine, right? So sine of this angle is equal to B over 6,5. So sine of that angle, and that angle is 90 plus theta, right? They told us that. That's where I'm getting it from. They told us that is opposite over hypotenuse, B over 6.5. Why am I not working with A? Because they're not asking me for A. Alright, if they asked me for A, I might have worked with cos instead, because then I would say adjacent over hypotenuse. Okay, they've asked for B. That's why I'm choosing to work with sine, because sine is opposite B over hypotenuse 6.5. Alright, so sine of 90 plus theta is B over 6.5. Okay, now does this help us? What is 90 plus theta? Are we remembering co-ratios? Whenever we have a 90 plus or 90 minus, we need to change sine to cos. Yes, I'm going to get to that still, alright? I'm getting to that still. I just first want to simplify this. So sine of 90 plus theta is actually the same as cos theta. Because guys, remember, which quadrant is 90 plus theta in? That is in the second quadrant, right? Because there we have 90. And if we add theta, we would get to the second quadrant. What is sine in the second quadrant? Positive. So that is why you change it to positive cos theta. Alright? So we actually get cos theta is equal to B over 6,5. Alright, now, which is even more of a stretch. Guys, this doesn't actually help us to solve B, because I don't know what theta is. And am I allowed to work it out? If they say without using a calculator, I'm not allowed to calculate theta. Okay, I need to think of something else. So I'm quickly going to write this down on the page. I haven't done that yet. Alright, so this is 6.1.3. We said that sine of 90 plus theta from the y-axis to line OS. It's the angle from the x-axis to OS. So sine of 90 plus theta was B over 6.5. And this is cos theta. Yes, exactly. That is the link. Someone is saying, didn't we solve cos theta in the previous question? Well done, Abby. That is exactly what we did. In the previous question, in 6.1.2, we calculated that cos theta is negative 5 over 13. And now we get sine or cos theta equal to this. All right? But cos theta is also equal to negative 5 over 13. This is from 6.1.2. So these two things are both equal to cos theta. So we are now going to say that since they are both equal to the same thing, they are in fact equal to each other. So therefore, B over 6.5 is negative 5 over 13. Okay, so that's a bit of a stretch, guys. Firstly, you had to recognize that this angle that you are drawing in here now, when you are constructing OS, is 90 degrees. Again, that's coming from this. They're telling us that the angle is theta plus 90. So the angle to that point was theta. So now if I'm drawing in another angle here from that line, that angle has to be 90. All right. Yes, the construction was hard. Okay. All right. Are we fine up until here? So if cos theta is equal to one thing and cos theta is equal to another thing, those two things are equal to each other. All right. From the x-axis. All right. So now we have that B is equal to negative 5 over 13 times 6,5. And if you work that out, I think it's negative 5 over 2. Let me just double check here. Yes, it is negative 5 over 2. So B is, in fact, negative 5 over 2. Guys, this was another problem-solving question. So last year's trig section was quite hard. All right, we haven't done that much, and we've already encountered 3 problem-solving questions. Okay. The rest, the next two weren't that bad. We are running out of time now, so I am going to skip 6.2. You can find the answer on y, the x-axis, because they told us that TOS is theta plus 90. So TOS, so it's that angle there. All right, they gave us the name of the angle, TOS. Okay. The next one, 6.2, I'm not going to do that. You can find the answer on, just to save time. All right, so you can find the answer to 6.2 on, what's it called, online, wherever. But 6.3, let's get to that because people have been asking for general solution and I want to get to that quickly. 6.3, they're asking for the general solution of 6 sine squared x plus 7 cos x minus 3 equals 0. Okay, so now we need to solve for x here. All right, what I want you to notice is that we have a sine squared. Sine squared, that is the key to this. All right, we have a sine squared and we also have a cos x. Now guys, you can't solve for x if you have different trig ratios. All right, you won't be able to factorize. Often with these types of questions, if you see that you have a quadratic, then you're going to have to factorize. Okay, you can't factorize here because you have a sine squared and then you have a cos and then you have a constant term. All right, so this is not something that you can factorize yet. But does it look like a trinomial? Right, it kind of looks like a trinomial. Okay, but the problem is that we have a sine squared and a cos. We can only factorize this as a trinomial if we have a sine squared and a sine, or a cos squared and a cos. Now guys, I'm not going to change cos x, okay? You're never going to change the cos x if you're doing like a trinomial vibe. We're going to change the sine squared one. Remember that we have an identity, sine squared x plus cos squared x equal to 1. Now if I want to have sine squared x, and I want to change that to something. I know you guys must know this. You must have worked with this before. That is 1 minus cos squared x. Okay, so sine squared x is 1 minus cos squared x. So that's what I'm going to do here, guys. I saw that someone said it in the comments already. So sine squared x, I'm going to replace with 1 minus cos squared x, so that I then have a cos squared x and a cos x and some constant terms, then I can actually factorize it. Okay, so sine squared x, I'm going to do this, 6, 1 minus cos squared x plus 7 cos x minus 3 is equal to 0. Okay, so now I'm going to multiply the 6 into the bracket. I'm going to say 6 minus 6 cos squared x plus 7 cos x minus 3 is equal to 0. Okay, now I'm going to just get this all in the right order because this is a trinomial, right? Because we have a cos squared, we have a cos, and we have constants, but these two are like terms, so let's simplify that. So negative 6 cos squared x plus 7 cos x. Then we have 6 minus 3, which is 3. So plus 3 equal to 0. Okay, guys, let's not entertain talk about having the paper. That's false. You can't possibly have the paper. All right, let's stop distracting people. We're actually trying to get through some work here. All right, so we don't like having a negative there in front of the 6 cos squared x, or I don't, rather. So I'm just going to multiply through or divide through by negative 1. So I'm just going to change all of the signs. You don't have to do this. You could use the quadratic formula straight away if you wanted to. All right, but now, guys, you can either factorize this or you can use the quadratic formula. If you like factorizing these types of trinomials, then go ahead, please. That's wonderful. If you want to use the quadratic formula, remember that you're not going to write x equals everything. You're going to write cos x equals everything. So I'm just going to show you quickly. I'm just going to write that was the question. Find the general solution for that. So I'm just going to write the quadratic formula down. It is on the formula sheet, so you don't have to write it down. But what you do have to show is what you are subbing into it. Okay, So this formula you don't have to write down because it is given on the formula sheet. But the next line you do have to write down. B is negative 7. B, remember, is the coefficient of the linear term, of the cos x term in this case. So we're going to do negative B, which is negative 7, plus minus square root B squared, so negative 7 squared minus 4. A is the coefficient of the squared term, so that's 6. And C is the constant term, so that is negative 3. That is all over 2a, so 2 times 6. You don't get a mark for writing the formula down, you get a mark for this line. Okay, so it's very important that you do this line. They give you the formula on the sheet, so they're not going to give you a mark for something that they've given you, but you have to show that you're subbing, or what you are subbing in for which values. Okay, this is very important. You're welcome, bye. So now you're going to type that into the calculator, and you are going to get 2 values, guys. For the first one, you press plus on the calculator. Then for the second one, you press minus. All right, when you do your plus, you're going to get cos x equals 3 over 2. That's the first one. Or cos x equals, let me just check, because I worked them out beforehand, it was negative 1/3. All right, so you get cos x equals 3 over 2, and you get cos x equals negative 1/3. Okay, so now from here, you're going to have to solve these 2 equations. All right. Now, what you do when you have these, I'm not sure how your teachers taught you, but I always say to my kids, okay, where is cos positive in quadrants 1 and 4? For this one, where is cos negative in quadrants 2 and 3? All right. Now I'm going to find my reference angles. Guys, remember for the reference angle, you're going to press shift cos and then the value. Okay, so 3 over 2 in this case. But guys, when you do this, it's going to come up as a math error. Because what is 3 over 2 actually? 3 over 2 is 1.5. And if we're thinking of the graph of cos x, y equals cos x, that graph only goes up to 1 and down to negative 1. It will never get to 1.5. It will never get to 3 over 2. So this equation, cos x equals 3 over 2, there is no x value that will give you, if you say cos of that value, that it will be equal to 1.5. All right. So if you type it into the calculator, I'll just show you quickly. Shift cos 3 over 2. You press equals. It says math error. That means that there is no answer for x in this equation. All right. So here you're just going to say no solution. So that's quite nice. All right, that the 1/2 of this question, of the 2 equations that we got, will have no solution. Okay, but for this one, we need to still do some work. So let's find the reference angle here. Now, guys, for the reference angle, I always use the positive value. Okay, some people do the negative value, some teachers. I'm not going to go over that method. I always just do the positive value, and then I just work in the negative quadrants. So I'm going to do shift cos of positive 1/3, and that will then give me an acute angle. All right, your reference angle always has to be acute. That is why no, it's not. That is why I never use the negative angle, because let's just quickly see if I do negative angle, I'm going to get something different. Okay, I'm going to get the second quadrant solution, which won't help me to get the third quadrant solution. Okay, so for your reference angle, you don't put your minus there, you always do the positive value, you get an acute angle. Now, for your second quadrant solution, remember, because cos is negative in the second quadrant, so you don't have to write Q2, you can just say x equals, you're going to do 180 minus the reference angle always for the second quadrant. Let me just get some space here. And now, guys, it's important to write that n is an element of integers. You lose a mark if you don't write that. Okay, so you do 180 minus 70,53 degrees, that's the reference angle, plus 360n because it's cos. If it was sine, you would also say 360n. If it was tan, you would say 180n. Okay, some teachers do k instead of n, that's perfectly fine. Some people put the n or the k in front of the 360, that's also perfect. Okay, don't worry about that. This is just how I write it. And now we just need to work that out. If you do 180 minus that value, you will get 109.47 degrees plus 360 n. That is the question there at the top. Okay, so that is the second quadrant solution. Now we still have to do our third quadrant solution, all right? For general solution, for sine and cos, you always have to have two solutions. Yes, you have to write n element of z, you do. Okay, so now x is equal to, in the third quadrant, it's always 180 plus the acute angle, 180 plus the reference angle. Let me just finish here and then I'll show you the question again, please. So 180 plus 70.53 degrees, again plus 360n. Now, if you've written n element of z before, you don't have to write it again. You can if you want to, but you only have to write it once. So now you can just calculate that in your head or on the calculator. That will give you 250.53 degrees plus 360n. Okay, and that is the general solution of this question. Now, someone was asking if it's always quadratic. It's not always quadratic, all right? I knew that it was quadratic because there was a sine squared in the first place, and then because there was also a cos x, all right? If it was just a sine squared and there was just a number, then it's not going to be a trinomial quadratic kind of thing, all right? But then you would have to still do technically like a quadratic kind of thing. Sometimes it's not a trinomial, sometimes it is, sometimes it's not a trinomial, sometimes you just have to take out a common factor. So if this was like 6 sine x cos x plus 7 cos x, right? If it was just that, and there was a cos x there, then you could take cos x out as a common factor, right? So it won't always be quadratic, but in this case it was. Yes, no, so not if the reference angle was positive, if this number was positive. So if this was cos x equals a third, okay, then you would work in the quadrant where cos is positive. So then you would work in the first quadrant, and in the first quadrant, it's just the reference angle, okay? That's what you do. You don't do 180 minus or 180 plus, it's just the reference angle. And in the fourth quadrant, you can just do negative reference angle, or you can do 360 minus the reference angle. Okay, so the possible x values if they asked you. Say they said in this question, they didn't say general solution, but they said like x must be an element of 0 to 360, for example. Okay, they can ask you that. Then you are going to use these two general solutions. Okay. It's not all going to fit on the page, unfortunately. Let me lift it up. There we go. Take a screenshot quickly, please. Okay. Yeah, we're running out of time, guys. We only have 6 minutes left. So I'm just quickly going to do this. If you have the specific solutions that they're asking for, if x is between 0 and 360. So now you're going to use these two almost as formulas, right? You're going to substitute n values into your equations, and that will give you x values. So you don't have to write these n values. I always start with n equals 0, right? If n is 0, you're going to have 109.47 plus 360 times 0, which is 109.47 plus 0. So that will then be 109.47 degrees. All right, and that is between 0 and 360, so that does work. Then you're going to make n equal to 1. Now, if n is equal to 1, you're going to have 109.47 plus 360 times 1, okay, which is plus 360. Now, if you have 109.47 plus 360, that's going to be outside of this interval, okay, that's going to be too big, so we're not going to do that. If it gave you a value that was inside your interval, you would write that value down. Now we tried n equals 1. We can try n equals negative 1 as well. So if n is equal to -1, this is going to be 109,47 minus 360, which will again give us a value that is too small for this interval. It will be smaller than 0, so that one won't work. So now we've basically exhausted all the options for this one. Okay, so if they've asked you for specific solutions, you are going to substitute n values. I always start with 0, then I do 1, then 2 if possible, then I do -1, then -2 if possible. Okay, for this one, if I make n equal to 0 here, it's 250,53 plus 0, so that's just 250,53, and that does lie between 0 and 360. So 250,53 degrees. If n is 1, it's going to be 250,53 plus 360, which is too big. It's bigger than 360. If n is -1, it's 250,53 minus 360, which is going to give us a negative number, so that's too small. So these would be the only two possible solutions between 0 and 360. Yes, you only do that if they give you an interval, which they didn't in this case, but someone was just asking how you would work that out, so I just made that up now, the 0 to 360 degree thing. Okay, and that's usually just an extra 1, possibly 2 marks. If it's like 4 values, they might give you 2 marks for it, but if it's only 2 values, then they will just give you 1 for that specific step. Yeah, in the 4 minutes that are left, we can quickly chat about some like exam, answering strategies, I suppose. Guys, literally just start with the questions that you feel most comfortable with. In paper 2, you get an answer booklet, so you get space for all of your questions. You don't have to worry about how much space you have to leave open for this. They give you literally like a block with lines for every single question. So if you feel like you can get lots of marks for the stats section, start with stats. If you feel like you are competent or confident in analytical, start with analytical. If you want to do the trig stuff first, do the trig stuff first. Basically do whatever you feel most comfortable with first. And guys, if you get to a question and it gives you a bit of a pause and you're like, I'm really not sure how to even start working on this, leave it out. Okay, come back to it after you've done everything else if you manage to finish that. I know that often people spend so much time trying to figure out, they struggle, they try to do various things, especially with these problem-solving questions. Guys, it's actually not worth it. You want to really get through all of the questions that you actually can do first before you even start spending time on the ones that you really have no idea of what to do. Okay, and like I said, there will be unseen questions. There will be problem-solving stuff. There has to be. Okay, you will definitely get problem-solving questions. So if you see something that's asked in a way that you haven't seen it asked in before, don't think like, oh gosh, I never actually, I didn't study this. Okay, everything that they ask you will have some kind of link to stuff that you've done. So see if you can find that link. But like I said, only do that towards the end. Okay, someone was asking here if I can make a TikTok video of the calculator stuff to press for stats. I have made a whole bunch already. There are videos on my TikTok on calculator steps. I still have to do one on regression line, so I'll do one on that tomorrow morning and I'll post it. Then someone was asking here for restricting the inverse. I'm not going to do that now. That's paper 1 stuff, hey? I'm just going through these questions quickly. Let's see. I can't go live tomorrow. Thank you for complimenting my handwriting. Guys, please go and look at my YouTube, okay? Some of you were asking for me to do more general solution questions. Guys, there are loads on my YouTube under the grade 11 stuff. Okay, I also, like I said, I recorded every single lesson for trig, every single lesson for Euclidean geometry. It's all on my YouTube under grade 11. Okay, so go take a look. I don't have loads of grade 12 videos up because I had an AP class this year, so we went through the work very, very quickly. We actually did a lot of the content in previous grades in AP already. So my grade 12 YouTube content is not as fleshed out as the others, but there's a lot of stuff in grade 11, guys, so please go take a look there. And you are very welcome. I hope that, that this was helpful. You can ask some questions. I'm going to post this on YouTube, yes. If TikTok saves it, just wait until this evening or so on, sorry. Yes, hopefully TikTok recorded it. Okay, thanks guys. Unfortunately, I have to go now. Please, there are loads and loads of maths videos on my TikTok. Please go take a look. I have lots of tips. I'm still going to post a few exam guidelines videos, things that you need to just make sure. I think there are similarity videos. Yes, I'm not 100% sure. You can just go check. There's nothing on eigenvectors now, unfortunately, but that's not in the core syllabus, so don't worry about that. Okay, guys, best of luck. If I can give you the top tip, work through past papers. Please work through the rest of this paper, work through 2019, work your way back. Okay, please, please, please work through loads of past papers and you will be all right. Okay, best of luck, guys. Thank you.